So in the last video we left off here, and now we're going to go back to the first page for number 5. I'm actually going to go here. Okay, number 5. So it's asking us to identify the segment of line where the substance is going from a solid to a liquid. So if you remember, we said over here was our solid, and over here was our liquid. So part where it's going from a solid to a liquid, it's going to be BC. Right? And what is it called when a substance goes from a solid to a liquid, right? Think of an ice cube turning into water. It's called melting. And that's going to be row 9, segment BC. Row 9, segment BC, row 9. Okay, melting or fusion. Okay, fusion is important if you remember when we get to heat of fusion and heat of vaporization. Okay. What would you call this part of the graph? We call this the melting point. And what is the change in temperature during this phase change? If we go back to our little chart that we have there, the change in temperature during that segment is 0 degrees. That's super important that the temperature is not changing while we're going through a phase change. If temperature is the measure of kinetic energy, average kinetic energy of the molecules, what can be said about the change in kinetic energy during this phase change? So if the temperature isn't changing, and the temperature is the measure of the average kinetic energy of the particles, then we can say that the kinetic energy is not changing. Okay, and lastly, energy of the substance is increasing, right? Because we're giving it heat. Heat is energy. So if we're increasing the energy, but it's not kinetic energy, then it has to be the potential energy. Right, so these are rows 10 and 11 for BC. Right, so the kinetic energy, like we said, is remaining constant. The potential energy is increasing as we are melting the substance, right? So we can say the same thing for when we are going from a gas to a liquid, right? That is called boiling or vaporization. And again, same thing. We're going from one phase to another. The line is flat, which means that there is no temperature change. And if there's no temperature change, that means the kinetic energy of the molecules is not changing. It's remaining constant. We are adding heat, so that means the energy has to be changing somehow. If it's not the kinetic energy, then it has to be the potential energy. Okay. And next up. All right, we did the same thing for that. Okay. And we finished this. Right, we're looking at, oh no, we haven't finished it yet. Okay, so back to what we were talking about here, right? If we're adding energy and the temperature isn't changing, then the kinetic energy can't be changing. But if the temperature is changing, that means the kinetic energy is increasing because, again, and I'm going to say it a zillion times, the temperature is the measure of the average kinetic energy. And then we can also say the same about when it's in the liquid phase and when it's in the gas phase. Change in potential energy. All right, so the average kinetic energy is increasing. Energy is potential plus kinetic. This is going to be remaining constant. Okay, and we didn't take a look at it here, or I didn't mention it rather, but when we are going from solid to liquid to gas, right? Solid to liquid, liquid to gas. It's not like, oh, I have a solid. There I go, I have a liquid. There's a point in between. The point in between, there is equilibrium, right? So you have a little bit of both going on. You have solid and a liquid at the same time here, because you're going from, right, you got your solid here, got your liquid there. Like I said, it's not just like, boom, we have a liquid, great. No, there is a period where it's called a phase change, right? Changing of the phase. And right there you have a balance of the two. You got some liquid, you got some solid. Same goes for going from a liquid to a gas, right? It doesn't just, boom, go from a liquid to a gas. There's a middle phase there. Okay. And the reason that I had you do the cooling curve for homework, right? It's the opposite. It's pretty much the same thing, just the opposite. So again, if you were lost on that or you want to talk about it, ask me that during the extra help session. And I think that concludes today's notes. Let me see if I missed anything up there. Where'd it go? Right, so we talked about everything. Yep. Okay. And well, I guess we'll talk about these now too. So where can you find the melting point of aluminum, or literally any element, most elements, on your reference table? Well, let's take a look. Reference table, our handy dandy reference table. Okay, doesn't seem anything here. Meh, no. There we go. Melting point, boiling point. And we have melting point for most of the elements, right? We got continuing down there. So when it's asking you about the melting point or boiling point, or like we'll talk about later, the freezing and condensation point of an element, this is where you're going to look. This is table S. Table S. Okay. And what's the second one? What effect does the pressure have on the solubility of a solid? That was old. That's from the old test. Pressure only affects gases. That one really threw you guys for a loop. You have to pay attention to the phase, right? The phase after the compound. All right, so the next and last lecture for today is going to be the March 6th notes. Okay, Peruli out.